The motion of a simple pendulum. Simple and predictable. We can easily predict the bob's position if we know the initial conditions. But things get interesting when we attach a second bob with the first one. The motion seems highly random, but we can predict the immediate future if we know the present. This is known as a chaos, and there are a number of instances where we get the glimpses, like convection of air currents. In 1963, Edward Lorenz and Ellen Fetter developed a model to have a good idea about atmospheric convection and gave these sets of differential equations. Now interestingly, when they are plotted on a 3D space, they got something which we now call the butterfly effect. This was one of the first instances where we got the glimpse of a chaotic behavior. Another example includes this equation. If you have watched this video by Veritasium, you must know what I am talking about. We got to see that the plot of R versus the stabilizing factor becomes chaotic at a point. Now, we have been talking about chaotic behaviors, but what is chaos actually? It is simply a dynamical system which seems random but is governed by deterministic laws. They are highly sensitive to the initial conditions, but they can't predict the future. Chaos theory finds its application in different fields like meteorology, anthropology, ecology, physics, economics, philosophy, and many more.